The following is a study on an unmanned aerial system. Name: Fire Rescue Intel Zoned Aircraft, or FRIZA. Length: 72 inches from the propeller to the end of the empennage. Wingspan: 90 inches. Maximum takeoff weight: 14.57 pounds. Maximum speed: 72.4 miles per hour. Maximum altitude: 400 feet. Designed to track and monitor wildfires, FRIZA employs a video camera attached to a rotating gimbal to record video of the environment below. A GPS unit is also located within FRIZA to transmit its coordinates to ground crews to further combat wildfires. The electronic systems that controlled the aircraft were located within the fuselage of the UAS. A simplified wiring diagram can be seen to include components similar to that in full-sized aircraft. FRIZA is powered by two Admiral Pro 4000 mAh 5S LiPo batteries. These batteries were placed in parallel to increase the capacitance within the electric circuit, therefore allowing for a longer flight time. Passing through a power module to distribute current, the circuit was divided into two sections: avionics and propulsion. To power the Hacker A50 DC motor, an electronic speed controller, or ESC, was wired in series to the motor. The ESC limited the current that the motor saw to reduce the probability of burning up. By controlling the current of the motor, the ESC also works as a throttle controller and brake. The avionics components included a receiver that allowed a transmitter on the ground to send signals to the craft, and a GPS unit to record locations. Servos were placed in the wing and empennage to activate the control surfaces. Following flight, the system could be connected to a laptop to obtain flight data including speed, coordinates, and altitude. A separate circuit was created to power the videography system as it required a lower current than that supplied in the main electric circuit. A battery pack was connected to a receiver and a gimbal. The receiver connected to a separate transmitter on the ground to allow for independent control of the camera gimbal system. The camera was internally battery powered, so it did not require a power connection in the circuit. The camera was wired, though, to transmit data, as noted by the dashed green line, back to the receiver for transmittance. On the ground, the observer could then obtain a first-person view from the camera using a specially designed headset. The electrical circuits can be analyzed using Kirchhoff's voltage law. Each element has a specific resistance that, when multiplied with the respective current, equals the voltage seen by the element. Manufacturers often provide specifications as to the levels of current or voltage an element can withstand without failing. When designing the system, an engineer must adhere to these recommendations to prevent failure. The DC motor element can be further analyzed by relating the electrical system to the mechanical rotation of the propeller. Using Kirchhoff's voltage law, the current can be determined. For this mechatronic system, however, the ESC controls the current and voltage via a throttle input on the transmitter. The mechanical portion of the coupled system can be mathematically explained by Newton's second law for a rigid rotating body. The EMF voltage and motor torque equations are used to couple the electrical and mechanical systems together. Using these coupling relationships, a system of equations can be found to simulate the rotational speed of the propeller based on the input voltage. FRIZA successfully landed 2 flights during the Boeing Aerospace flight demonstrations.